Imagine you're staring at an old, disassembled toaster spread across a bench at MIT. Kevin, Otto, and Kristin would show us how reverse engineering this clunky mess isn't about copying, it's about unwrapping secrets. They turn teardown not into destruction, but the birth of fresh ideas. But why is ripping products apart one of the smartest ways to learn design? That question hooks us into a modern design cycle unlike anything you've heard before. Start with a toaster teardown. Sounds simple, but it's a deep dive into product DNA. Here, why dissecting beats just building. At MIT, Otto and Wood took apart a common toaster layer by layer, not just to find broken parts, but to study every snap, joint, and screw placement. They noticed how everyday products hide clever compromises, materials chosen for cost, safety, or user pleasure. This wasn't random disassembly. It was a systematic observation of a product's underlying why, a crucial first step in design mastery. Reverse engineering acts like detective work. Think Sherlock Holmes scrutinizing clues. Every screw size, every circuit layout tells a story of trade-offs and priorities. Just like Holmes builds a hypothesis on evidence, designers form ideas by hypothesizing why a product is built a certain way. This hands-on mystery unpacks complex design decisions better than lectures ever could. That deep insight transforms your approach from copying blueprints to understanding product intent. Suddenly, you're no longer just assembling parts, you're grasping the why behind designs. This unlocks intuition to create smarter, more user-centered products. The payoff? Design graduates who think critically, not just technically. Otto and Wood propose a fresh learning cycle. Experience, hypothesize, understand, then build. Let's unpack how this changes everything. Rather than starting with theory, you first handle real products. Feel textures, test functions, notice flaws. It's sensory discovery that grounds your perceptions. For example, when breaking down a blender, you can actually see how motor placement affects noise and vibration, a precious sensory insight missing from textbooks. Next, you form hypotheses. Why is that motor mounted off-center? Maybe to dampen sound. These guesses steer your experiments. Like a scientist, testing these hunches uncovers new understanding. This step moves a designer from passive receiver of knowledge to active investigator controlling their learning experience. Finally, armed with this deep understanding, you execute designs confidently and efficiently. You don't waste time on guesswork or endless revisions. Instead, design cycles accelerate. The ultimate insight. Mastery happens when intuition gained from real-world experience fuses tightly with rigorous analysis. It's not just about cracking the product's secrets, but how to build tools and processes that map customer needs to real designs. Otto and Wood highlight benchmarking as a North Star. For instance, comparing a chair's ergonomic specs against market leaders creates clear engineering goals. This means you're not guessing what users want. You've got data guiding every design decision. Benchmarking bridges creativity and reality in a powerful way. Concept selection isn't just picking a favorite idea. It's a disciplined process weighing user value, feasibility, cost, and risk. They liken it to auditioning actors for a movie. Each idea must pass tough tests to make sure it fits the story. This brings structure to creativity, producing smarter, viable designs. Designing for manufacture and assembly isn't an afterthought. Taking the environment and production into account early leads to fewer costly errors and a smaller footprint. Think of it like cooking a meal where you plan ingredients to minimize waste and maximize flavor. Great design tastes better when it's efficient inside and out. Remember our MIT toaster teardown? What began as curious disassembly became a powerful learning cycle. Observe, hypothesize, understand, execute. Now you know why tearing apart products isn't just destruction, it's the birthplace of invention. Next time you hold a gadget, try this. Take it slow, ask, why is this here? And imagine building it better. That's the best design lesson you'll carry going forward. Subscribe for more book summaries like this one.